have rocks that float, literally that have low specific gravity.
Like pumice?
Pumice would be prime example, P-U-M-I-C-E. Okay, and that pumice forms when you have a lot of gas in the lava. And there's a phenomenal amount of gas in the lava, pumice will form because literally it's the explosion of gas out of the lava. The most common gas in lava is water vapor, H2O. It's the most common gas in lava. Okay, we've got the rocks on the surface. Now let's, yes.
What does it say in
Pumice, low specific gravity.
Okay.
Okay, we got the rocks on the surface. We're going to do something called weathering. Weathering breaks them down. It reduces the bedrock into what? Yesterday. No, is not the answer. Bedrock is broken down into regolith. Regolith is broken down into sediments. And sediments can be moved. So the breakdown from solid rock to sediment, that process is referred to as weathering. And it's done by physical and chemical processes. What happens if Ray were to put his beer bottle in the freezer and forget about it for 2 weeks?
It would explode.
What?
It would explode.
It would explode. What would happen to the bottle? It would fracture. Bam, same thing happens in nature. Come January, when there's water within rock units, that water's going to freeze, zap, your rock units are broken apart. Physical process. You also have chemical processes. So chemical weathering will break down solid rocks. Weathering produces sediments. And sediment is any size. Any size. Clay, sand, gravel, boulders, cobbles, you name it. Any size of broken bedrock. There have been sediment particles that are city block size. So sediments are just broken up bedrock. With luck, erosion is going to take place and move those sediments. What types of erosion do we have here in central Wisconsin? Water. What else? Wind. What else? Go back 2 million years. Glaciers. What else? Gravity. Gravity, the universal mover, moves more materials than anything else. So sediments are being moved. Just like anything moved, it's got to be dropped. So we have something called deposition. Dropping sediments is deposition. Bam, there it is. It's deposited. And if it's deposited in layers upon layers upon layers, we have the possibility of forming a sedimentary rock. And this is what separates this is one of the things that separates sedimentary rock from everything else. It forms layers, the rocks form layers. And there are various types of sedimentary rocks, not just one, but various types. First of all, we're taking this sediment, it's being transported, and dropped. This is referred to as a clastic sedimentary rock, C-L-A-S-T-I-C. Prime example, sandstone. You take pieces of sand, you put it together in a rock, it's plastic, it's gritty. Sandstone is a plastic sedimentary rock. Some materials are in solution. As the water runs across the landscape, it dissolves substances like this. What is this again? CaCO3? calcium carbonate. Add water to this and you dissolve the calcium carbonate. Eventually the stuff in solution must precipitate out. Any coffee drinkers here? One, add sugar. Put that sugar in your coffee cup, let the coffee cup sit for a while. You stir it in first, let it sit. What happens to your sugar? Dissolve, but you let it sit longer. Okay. It will begin to precipitate out. It will begin to form on the bottom. So if you're a coffee drinker like I am, you take a cup at the beginning of the day, you let it sit, you find it again 3 weeks later. It's got all this great green stuff in it. Well, if it precipitates out, it's referred to as a chemical sedimentary. And if it's plant or animal remains, it's organic. So sedimentary rocks may be plastic, chemical, or organic. Let's say we pile a mess of stuff on top of this. We just load it up with heat and with a lot of material. And we cause a partial reconstitution of the material. We don't melt it, but we cause a partial reconstitution. In other words, a few of the grains will begin to melt. This is your metamorphic rock. Rib Hill. Rib Hill here in downtown Wausau.
2 minutes.
Rib Hill is a metamorphic rock. Rib Hill started out as sandstone, and it has undergone change, but it has undergone change at great depth. Again, buried, exposed, exhumed after a period of time. Hardwood Hill, Mosinee Hill, all of these are metamorphic rock. They're all sandstone that have been converted. Okay, what's left? We can add heat and pressure to this metamorphic and melt it again. And you have magma, and this process starts over again. What are the odds that Rib Hill is going to be melted down? Virtually none. So what's going to happen to Rib Hill? It's going to undergo weathering and become sediments. So it's a continuum here, not a one-way process. So you'd have sediments, goes through the cycle again, gets recycled one more time. So the rock cycle is literally changing from igneous to sedimentary to metamorphic by various methods. Okay, now this is where your exam will end. And it's the next chapter for both books. I don't recall the page number. But the geologic timetable is at the end of the chapter. And I put it in front.